Okay, so in calculus, there are three big concepts. Number one, limit. Number two, derivatives. And number three, integral. You don't have to write this down, but it's just going to be what we covered the whole year. So we are going to start with limit. And limit is going to be the first chapter. And then we're going to spend like the entire first semester, the rest of the first semester, on derivative. And then second semester is all integral. All right, so if you are like, this is a lot to write down. Okay, so let me just start with what you need to copy down. First, limit as x goes to a of f of x equals L. This is the general limit definition. Or this is generally how you write limit. Okay, so what does that mean? First of all, I need to make sure that everybody writes exactly the same way I'm writing. So limit goes first. Okay, so make sure you write limit the same way I write limit, and then x goes to something. F of x has to come next, okay? Some of you write limit without any kind of function next to it. It makes no sense. So f of x equals L. What does this actually mean? So it means, this is the definition. So if f of x becomes arbitrarily close to a single number L as x approaches c from either side, then the limit of f of x as x approaches c is L.
Are we writing that on note?
Or you can write the general idea of it. So basically what it's saying is when x is going to c, your y or f of x is going to L. You know, we kind of did that chapter 10 last year, the last chapter. So, or kind of throughout the whole year, we kind of did like end behavior or like at asymptote, some stuff happened. But basically, when x is going to a number, y goes to somewhere, right? If y goes to a number as well, then that is the limit. Now, when x goes to a number, x can go to that number from both sides, right? So then we're going to talk about what happens when it goes from this side, and if they are the same number, or if they're a different number, or they don't even go to a number, what does that mean? But either way, it has to be x goes to a number, and then we're going to talk about what that means. F, which means y, goes to a number, then that number is called the limit. Yes, Zach?
Is it supposed to be C? Or is it
Yes,
A?
it's C or A.
Oh, I'm sorry. Let's change this one, though. Let's see.
We get it.
Wow.
Okay, so that's what limit means. Okay, so I'm going to show you three graphs. You're going to write down what you think the limit is based on your understanding of this definition. Remember, the part on this definition that is, I guess, the most important, or one of the most important, is arbitrarily close. Arbitrarily close means it's getting close to, but it doesn't have to equal. So when an x is trying to get to this number, it doesn't have to be at that number. It's just trying to get there, and then y goes somewhere. Okay, so please remember that definition. Now let's look at this first one. Okay, this graph. Limit as x goes to -1. F of x equals, write down what you think it is. So when x is going to -1, y is going where? So that is the question. Write down what you think the answer is. All right, write down what you think. The answer is. Okay, so let's vote. How many people think it's -1? How many people think it's 2? How many people think it doesn't exist? Okay, the answer is -1. So the limit as x goes to -1, okay, we said x goes to -1 means it's getting close to -1, so that's when x is getting close to -1. Y goes where? Y goes to -1. Now, does it exist on -1? No, but it doesn't matter. We said arbitrarily close.
Isn't it exactly on 2 then?
Well, the question is limit.
Yeah.
Where is the limit? So when x is trying to get to -1, where is y trying to get to? Y is trying to get to -1. Well, what is it going on at -1? It's 2, but that's not what the question is. Okay, so that's what limit is. Limit is what is it doing from both sides. Okay, what is it doing from both sides? It doesn't have to equal something on that point. It just has to get there, try to get there. All right, next one. Same question, different graph. Limit as x goes to -1 of f of x. Limit as x goes to -1 of f of x. All right, what do you guys think? -1, because it is -1 and it is going to -1 from both sides. So there is no arguing what that number is. It is -1. Last one. Same question. Limit as x goes to -1 of f of x. What is it? -1, yes. We don't care if there is a number on -1. We're just asking where is it trying to go to. All right. So that is graphically. What if you are given a table? Don't copy this table down. Okay, just understand the whole idea. Okay, so let's say that they give you this function. And then they give you a lot of numbers that you will actually find if you plug in all these x values. The question is, when x is getting to 1, where is y going to? What do you guys think? 3. Right? You can see this number is getting bigger. Y is getting bigger and bigger and getting closer and closer to 3. The same thing on the right-hand side. When x is getting close to 1, y is getting close to 3. And then the same thing on this side. When x is getting close to 1, y is getting closer and closer to 3. So the limit is 3. Does it have to be defined at 3?
No.
No, we're just saying that the limit is 3. So there might not actually be a number. There might actually be nothing here, but the limit is 3. Okay, so this is how you look at it from the graphical way and from a tabular way. Now let's look at actual equations. Find the limit of f of x as x approaches 2, where f of x is defined by a piecewise function. Okay, so find the limit as x approaches 2. So how do you write that? Limit as x approaches 2. What is f of x is the question. Okay, when x is going to 2, what is y? Okay, talk to your partner. Use that piecewise function. If you have no idea how to use it, draw a picture of the piecewise function. It's not a hard function to draw. So it's basically saying when x is not 2, y is 1. When x is 2, y is 0. Okay, go ahead and talk to your partner. Okay, so we only have maybe 3 choices. Okay, so how many people think the answer is 1? How many people think the answer is 0? How many people think the answer is no answer, no solution? Okay, all right, let's go ahead and look at this graph. So let's just graph it. It's basically saying when x is not 2, so 2 is the most important thing here. When it's not 2, it's the function is 1. So basically it looks like this. And then what happens at 2? At 2, it's 0. So what is the limit? 1. Okay, so how are we going to be able to actually do this without a graph? Well, all you need to do is look at this piecewise function. So basically, remember the definition of limit is what is it doing from both sides? From the both sides of 2. From both sides of 2 means not equal to 2. Right? I don't care what's going on 2 because it could work, could not work, doesn't matter. But I just want to know what's going on from both sides of 2. Both sides of 2 is just the not equal to 2. So that's all I'm looking at, the x not equal to 2. Yeah?
I understand how that works, but couldn't it also be like a downward slope or something?
No, because it's just saying the function is equal to 1. 1 is a flat line.
Oh.
Yeah. All right, let's go ahead and look at some practice. So this is the graph here. Do you remember these? Okay, so 2, sorry, this one's kind of stuck there. So look at this graph here. Go ahead and do number 1. Limit as x goes to 0. Okay, so what do you guys think the answer is? 0 or 2? Or does not exist? Good. Does not exist. Okay, remember, limit by definition is x going to that number from both sides. From both sides. Both sides have to go to the same number.
It's going to 2 from 1.
Yeah, so if they're kind of jumping, has to jump this continuity, it doesn't exist. Yes?
Is does not exist the same thing as undefined?
We just say does not exist. Yeah.
The limit does not exist.
Okay, let's try another one. Let's do number 2 here. Limit as x goes to 1, f of x. Oh, that's an easy one. Ah.
Yeah.
Yeah.
What's the answer?
1.
1. That was too easy. Okay, try this one. Limit as x goes to 4. 4. Yes. Good. Where is 4?
4 is gone.
Okay, so let's kind of talk about limit again. So what are the cases when the limit does not exist?
So the 2 sides are not.
Right. So first case. So there are 3 cases. First case, when the left-hand side and right-hand side are just not going to the same number. Okay, does not matter if they're both wholes, does not matter if one of them is a solid dot. As long as they don't go to the same number, it does not exist. So you just want to write that down. Left-hand side, right-hand side has to go to the same number. Or you can say, when they don't go to the same number, it does not exist. Or you can draw a picture. You don't have to write everything down. And all this stuff is in your book. So I just took the book and then made some notes. So all you have to do is just, get the picture from your book. Okay, so first, left-hand side, right-hand side, if they are not the same number, then it does not exist. Second case, when they go to infinity. Infinity is not a limit, so we'll talk about that a lot later on. But if one of them goes to infinity, any kind of unbounded actions, unbounded means it goes up forever or goes down forever, that is not a limit because we can't cap infinity. Okay, so that's not a limit. So then anything that goes to infinity is called does not exist. So infinity and does not exist actually mean the same thing.
So could you put either or?
Correct, yes. Yeah. Okay, so unbounded or infinite limit does not exist. All right, third case. Third case is a little bit strange. Third case means that it goes up and down, up and down, up and down forever. That is, limit does not exist. Because we can't decide what number it actually is, so then we say that limit does not exist. So for example, this one, when they ask you, what is the limit at 0? Well, we don't know. When it's getting close to 0, it keeps going up and down, up and down. So then that limit cannot exist because it can't stop at a place. What is the limit when it goes to infinity? Well, obviously, it's kind of curving down to a place. So we'll talk about it later, but there is a limit. But anyways, when you're trying to get to a number and x is going to a number and then y goes up and down forever, so it oscillates, that is, the limit does not exist. So 3 cases where the limit does not exist. Good?
Yeah.
All right, so let's go ahead and let's have you try. So I'm going to show you how to do this algebraically later, but for now, all you can do is just use your calculator. So graph it and look at it and say, what is the limit as x is going to this number? Okay, so come back. So what is the limit? 0.25.
What?
Huh?
Is it 0.5?
0.5.
Oh, right. Sorry, 0.5. Sorry about that. Okay, how about this one? Try this one.
Oh, thank you.
And then one thing, you may be using your calculator in multiple classes, but in calculus, your calculator has to be in radian all the time. If you're taking AP Physics, your teacher will probably tell you to leave in degrees, so make sure when you come to calculus, change it to radian. We're just always in radian.
Always?
Yes, always. We never change it to degree. No matter what. No matter what.
Is it a sin to have it in degrees in this class or degree in this class?
Okay, keep it in radian. Okay, what's the limit as x is going to 0 of this function? Yes, does not exist. Very good. Yeah, oscillating does not exist. All right.
So that's what